Oh, welcome back, guys, and hope you enjoy the videos and enjoy the day you have. For every day is a fresh day, and it's always good to learn some math or like refresh your a bit memory. So last time we talked about what do we mean by integration or anti-differentiation, and in 11E we will learn a bit more or one step further, right? So the integration actually tells us the signed area. What do we mean by signed area? So the area is bounded by the x-axis. If it's above the x-axis, when we do integration, we got positive. And if the area is bounded by the graph is below the x-axis, so we got negative. That's why we get the signed area. So if question is asked us to find total areas, you need to calculate both separately, then adding them together with absolute value. Okay. For example, my A1 is 3, my A2 is -1. So my total area is going to be 3 plus absolute value -1. So essentially it will be 4. Okay. For the rest of them, it's pretty straightforward. You just need to plug the number and to get the values. Okay. The only one thing I want to emphasize here is this guy. So if I use 1 over 2 fx dx, I can use negative 2 over 1 fx dx. Okay, I can add a negative sign in front of this guy, then I swap the upper and lower boundary. Okay, so this is 11e. And for 11f, again, they try to ask us to find the area under the curve. So first, the area of the region is a to the b, and fx. If it's below, again, you can make a negative sign in front of it, a to the b, or you essentially change to b to the a, okay, to give you exactly the same thing. And again, if they cross the x-axis, which means they have the negative and they have the positive, so you have to be a to the c, calculate one area, and c to the b, calculate another area. Then you add them together to get the total area. If you do a to the b in one integration, this one essentially gonna give you some really small number, or even give you like the 0 if they are the same. If this one is 2, this one -2, you directly do a to the b fx, this will give you 0. Okay, be careful with this one and make sure you calculate them separately. Okay, and let's keep going. This example is pretty straightforward. And 11g is integration in circular functions. So remember, the sine x derivative is cos x, and my cos x derivative is sine x. So we need to remember it reversely. So my sine x anti-differentiation will be negative cos, and my cos anti-differentiation will be sine. Okay, and this one is just use formula to familiar with all of this. And 11h, the miscellaneous exercise. This one is pretty important because this one is combined with our derivative and anti-differentiation, and it always asks to know what mean by differentiation, and sorry, what's the link between derivative and anti-differentiation. Okay, they always ask us to find derivative first, then find anti-differentiation. So let's look at some examples. For example, if my fx is x to the log ekx, first find the derivative, then we use product rule. So my f dash x is log ekx and plus x times 1 over x. So it's essentially just 1. Okay, just make it 1 over here. Then get rid of this one. This is my derivative. And you realize question is ask us to find anti-differentiation for log e kx. So let's look at this one. You realize my log e kx is inside this function. Okay, so I can do both sides for anti-derivative. Then this part, I use green one. This part is what I want. Okay, and this part is essentially just x. And this part, derivative and anti-differentiation, they can cancel with each other. So the remaining is again my fx. So it will be my x log e to the kx and minus x. We move to the left, of course, plus c, okay, to equal my log e to the kx. Okay, this is the whole idea of this topic. For every time, they're gonna test us for this one, and we need to make sure you are confident about this calculation and make sure you can do it properly. Okay. It's 24 and exercise always find derivative first, then find anti-differentiation. Okay. Another one is 11i. 11i is like the area region between two curves. So essentially it means we no longer bounded by the x-axis. We like the area between two curves. So first one is AB fx dx. So essentially they calculate this area, this big one, and then a to the b over gx is calculated this one, okay, bounded by the axis. So if we minus between them, we got the green one, okay, which is this side. So the big area minus the small area, this is what they want. And later for this one, if help you guys memory, is always the upper function minus the lower function. Okay, let's see it again. It's always upper minus lower. This is going to help you to remember this, find the area region between. So let's look at this one. So my upper is this one, and my lower is my x squared. Okay. And same apply over here. My upper is the red one, so 4 minus x squared, and my lower is the gray one. Sorry, the blue one is my x squared plus 1. And if we have the upper lower is changeable, like up and down, so for each of the area we have to do is separate. Okay, again we need to do it separately. Do one region by one region. Okay, and it's again up and down, up and down. And let's look at this example. So for example 28, even the graph is below the x-axis. Again, we apply for up and down things. So in this case, from -1 to 0, my upper is x cubed, and my lower is my x. Okay, so essentially the same thing. And once you apply for the upper minus down stuff, it always give you the positive areas. Okay, so this is this one. And make sure you guys read example 30 carefully, and if you have any questions, please let me know, because this idea is important. It help you guys or help us to find the area of the inverse functions, to use this idea to help us find the area of the original functions. Okay, and the property is symmetry over here is pretty important. And for the next one is application of integration. So what do we mean by the average value of a function? It essentially means if we want the average, we make this really weird shape, and to become the same base, which is a to the b, and the average value of the function is the rectangular height. Okay, so the average value is the height of the rectangle having the same area as the area under the graph. So essentially, we can use this one to calculate the, if we change it to the normal rectangular shape, we can get the height value. This is the average value geometric meaning. Okay. And for the next one is motion in straight line. This one, like we talked in chapter 9, just remember x, v, and t. So they doing the derivative respect time. Again, derivative respect time. And sorry, this one should be my A, acceleration. And the anti-differentiation respect time and anti-differentiation respect to time. This is the thing we need, okay, for our motion applications. Okay. Again, if we talk about the rate of change, we need really depend on the question, and sometimes they ask you to find the maximum rate of change or maximum rate of decrease or increase. Is linked back to our chapter 10 stuff, which is second derivative, and to find the derivatives maximum or the minimum. Okay. And this is fundamental theorem of calculus. We don't need to know. If you have time, you can look at this one. And that's all for the chapter 11. So the chapter 11, two key messages. First one, understand what do we mean by integration. It just means the area under the curve. And second one, just practice and exercise how to find the area properly and efficiently. Okay, hope this video is helpful, and for the next one we will move on to the probability. Okay, and if you think this one is useful, please share with your friends and leave any comment you want. Okay, thanks for watching guys. See you for the next videos. Bye bye.